Cosine law, part 2. That's 2 in French, eh? I teach math, but I can teach other things. 30-3s, here we go. Cosine law. Last period, we talked about cosine law and how it is a formula that is used to calculate a side length. We can calculate A if we don't have a right angle triangle, but this solves a side. Remember, cosine law, non-right triangles, no right angle, and when we solved for a side, we did not have any true angle-side pairing. We didn't have an angle and the side across from it, because the angle-side pairing, an angle and the side across from it, that would allow us, remember, to use the sine law. We didn't have angle-side pairings, so that formula helped us, the cosine law, to find a side length in a non-right triangle when we couldn't use the sine law. So today we're going to talk about, on page 19, angle calculations. Well, again, non-right triangles, but no angle-side pairing. So if we take a look at the triangle that's here, the triangle, this situation, we wouldn't know what B or C is. This is the information we would have. We would want to calculate how big is angle A, and we would have 3 sides. Well, given 3 sides and no angle, again, no angle side pairing. We want angle A, which we don't know, so that's not an angle side pairing. And without B or C, there's no angle side pairing. So again, sine law won't work, so we use the cosine law. Cosine law, a formula you just need to be able to plug into and solve. Couple things that are important before we jump into it though. Please note that we don't calculate angle A with this formula. This formula, all that stuff on the right side, gives us the cosine A value. So we're going to end up with cosine A equal to, when all that's punched in, some decimal value. Here's this important box. Just like right triangles, anytime we're finding an angle, we're going to have to inverse to calculate the final angle size. Same idea. Cosine A is what we'll solve for, which is a decimal. We'll have to second function or inverse to get the angle size. And please note that everything in that formula is lowercase b, c, and a, so we're dealing with side lengths. Lowercase is side lengths. If we know all 3 sides, we can use that with the cosine law to calculate the angle. So, formula-based, let's take a look at it. Take a look at page 19. Page 19, there's your triangle. We want to calculate the size of angle A. Well, if we want angle A, again, no other angle is given. A we don't know. No angle side pairing, no sine law. So we want to plug into the formula. Let's label first. Across from angle A is side A. Across from angle C is side C. Across from angle B is side B. Label correctly so your formula will work. So we end up with cosine A is B squared plus C squared minus 12 or A squared. And all of that has to go over 2 times B times C. So it's simply plugging into the formula, but now we have to be really careful when we solve. Again, this is an awful lot to punch into a calculator. My suggestion, punch it in bits and pieces. Get a value for your numerator, get a value for the denominator, the top and bottom, and then calculate from that. That's what I suggest. So when we do A squared 8 squared plus 10 squared minus 12 squared. We add the first two and subtract. We should get 20. When we do 2 times 8 times 10, we should get 160. So when I do 20 divided by 160, my cosine A will equal 0.125. But that's not our final answer, because our final answer requires us to find the angle. We need to second function or inverse cosine 0.125. So go to your calculator, check that you're in degree mode, second function cosine 0.125, close our bracket, take the angle to the nearest degree, 82.8, rounds up to 83 degrees. So angle A is 83 degrees using the cosine law. Hopefully it's fairly straightforward. I really believe as long as we can label our sides correctly, plugging into the formula is not that bad. It's making sure that we can get the appropriate values. Same question, but now we want angle C. Now, like we talked about with the other cosine, our formula works for cosine of A. But this time, we want to know what angle C is. Our formula works if we're finding angle A. What I like to do is I'm going to change the labeling then. Since we're trying to find angle C, but our formula is always finding for A, I'm just going to recall that A. But if I've changed C to A, I have to make sure I change A to C. Our B is still okay. B doesn't get affected. But if we're trying to find C, I need to call it A, and my A needs to become C. So now I have side A, side B, and side C. Make sure you're punching the correct values into your formula. Now, just very quickly, some of you may have said, you know what? I know we're finding angle C. What does that mean in my formula? Well, our formula means if we're trying to find for A, we have to subtract A. So if we're trying to find for C, we're going to subtract C squared, which means we would have B squared plus A squared now, because I've changed A to become C, so my C needs to become an A, my C needs to become an A. You could manipulate your formula and use the initial labeling. Me, I like to change my triangle. I just find that works a little easier for me. So cosine of A, B squared plus C squared minus A squared over 2 times B times C. There's our formula. Trying to calculate angle A, which is our angle C initially, and now we can solve. Cosine of A, 8 squared plus 12 squared minus 10 squared. When I do that calculation, we should end up with 108. 64 plus 144 minus 100. And that's over 2 times 8 times 12. 2 times 8 times 12 gives us 192. So we end up with cosine A equal to, this became 108 over 192. Turn it into a decimal. 108 divided by 192, and 108 divided by 192, sorry. We end up with 0.5625. 4 decimal places. When we have that, that's our cosine value. So like we've talked about, inverse, second function, whatever your calculator is, cosine. Decimal 5625, So very quickly, second cos 0.5625, and we get 56 degrees. Angle A is 56 degrees, so this is a 56-degree angle. There you go. It was angle C, so angle C is 56 degrees. There's your cosine law. One more. Let's go to page 20 and take a look at the question on page 20. Page 20 is a straight up triangle. Gives us information, doesn't give us the triangle. So we just need to sketch the triangle a bit. Label it. We have angle R is what we want to find. We have side QR. So there's QR, which I'll call 9.4. We have side RT, so I'm going to call that T because side RT is 12.8. And we have TQ, it gives us is 8.2. And we're trying to find angle R. Again, first thing I'm going to do, formula solves for A. I'm going to change my R to A. And I need these two then to be BC. I've labeled it. Doesn't matter now that I've changed my labeling, as long as I know that what I'm finding, that angle, because it was R initially, is angle A now. So we have side A, we have side B, and we have side C based on our labeling. So now that I have ABC, now I can substitute it in. Cosine A, B squared, 12.8 squared, plus C squared, which is 9.4 squared, subtract A squared, which is 8.2 squared. All of that is going to be over 2 times the B value times the C value. There's the substitution, and now we solve. Again, I like to break it into the numerator calculation first. 12.8 squared plus 9.4 squared, subtract 8.2 squared. That gives us 184.96. And that goes over 2 times 12.8 times the 9.4, which is 240.64. So I can divide these, and I get a decimal value, in this case, of 0.7686. Once you have your 0.7686, have to finish second function, cosine, inverse, whatever you want to call it. Angle A works out to be 40 degrees. There's the cosine law to find angles. Not a big, tricky situation. Again, labeling is where you can get messed up if you don't label carefully, and make sure you always have to second function inverse cosine. Punch into your calculator carefully. It's a matter of being focused. Lots of little steps. Assignment booklet, page 22 to 24. 2AB, 3, and 5B. Not a lot of questions, but get these down pat. We're going to bring sine and cosine law all together next period. So make sure you understand sine law. Make sure you understand cosine law, both angle and side calculations, and we'll go from there. See you next time.